looks like we all made it back. I'm sure there's some more people be coming in as we move along. But let's get started. So what I wanted to talk about today is somewhat different from some of the other talks that you've listened to yesterday and probably what you're going to listen today. We're going to talk a little bit about history, a little bit about some stories, a little bit about culture, a little bit about technology, and we'll put it all together as one story. Sometimes I've done versions of this as a day-long workshop, at some conferences. So I've abridged the whole thing into 45 minutes that we have. So I'm going to go pretty quickly. If you want to make some notes for questions and all that, please do. But if you want to talk about it later, we're happy to do that too. So if you missed my colleague Marco's presentation yesterday, you probably didn't know what ThoughtWorks is. Is there anybody here who hasn't heard of ThoughtWorks before? I've never heard what ThoughtWorks is. At least, yeah, a couple of people. So for your benefit, just to recap, right? ThoughtWorks has been around for about 30 years. We have been in the forefront of pretty much every software advances that you can see over the past 30 years. Agile Manifesto, we have our signatories in there. You probably heard of refactoring and strangler-fit patterns and all those things came out of ThoughtWorks. Microservices came out of ThoughtWorks. Continuous delivery came out of ThoughtWorks. Continuous integration came out of ThoughtWorks. If you have done testing and activities like that, Selenium came out of ThoughtWorks. And this is only some of the things that came out of ThoughtWorks, right? But we have had a very rich history of doing this. So over the 30 years, we started as more of a thought leader in a lot of these areas. Like you can see here, we have written lots of books on pretty much everything that you can think of. We'll be referencing some of the books today. But we are not like a think tank, right? We are actually a consulting company today. We used to build products like GoCD, like I spoke about Selenium. If you have, cruise control, if you have used it, those are all products that came out of ThoughtWorks. But today we don't develop any more products. It's mostly about consulting. So we basically are one of the unique consulting firms out there. We're based out of Chicago, but it's all around the world. We don't have one in Poland, and that's one of the reasons I'm here. Just trying to see what the interest is here, So, but we are in about 18, 20 countries or something today. So let's also talk about the context of why I am talking about this, right? I've been in the industry. I got a lot of gray hairs. You probably know that I've been in the industry for many years, right? So before 2009, so we're going to take 2009 as that seminal year when this DevOps term came into existence, right? So before 2009, I don't know, you can read all of those things, but essentially what I was trying to do was I did some hardware, software design. That's where I got in the industry after my, doing my engineering training and all that, and then I started doing some kind of application development for developers. Then I started looking at the productivity for the developers, because the team I was working in during those days, they were not very productive at all. I said, how can I make them more productive? So we started building tools around some of those kinds of things. Then we started having this whole idea of SDLC, right? So software development lifecycle. So how do you optimize SDLC and those kinds of things? Then we started really getting into some of the actual benchmarking activities, because so you would see that all these things are the seeds that actually created DevOps later on. So after 2009, my jobs, again, there wasn't like a year 2009 that changed my career, but around 2009 started doing a lot of other things, So essentially we started looking at things like, what's your end-to-end business life cycle? It's all great to have your software, but how is software contributing to the actual business outcomes? We started thinking about a lot of those things. So we started doing like more of global product delivery, and I became the SVP, VP of a couple of big companies. So I started having large teams where the productivity was a big challenge. But also people are always thinking about okay, how do I actually map that productivity into something that is more applicable for the business? So finally, I ended up becoming, the head of platform engineering at ThoughtWorks. But if you really look at these two cycles, nothing much has changed, right? Because there is a core business activity there. There is whole thing about collaboration. There's whole thing about communication, a holistic view of things, as well as measuring and improving and eventually outcomes, right? So business doesn't change. Even if you talk about things like microservices today or platform engineering today and all that, these are exactly the kind of things that we used to do 30 years back. You have a different name, right? Because we always had modular architecture for building software. We had libraries, and we used to actually have economies of scale based on that. So we are really rethinking the way we are actually doing our current work based on what we have learned over the years. So what I'm going to do today is I'm just going to go through 15 different things. You may or may not agree with these 15 things. The reason I picked 15 was that, today, 2024 is that 15th year of the term DevOps, right? So I picked 15 of them. So I'll quickly go through that. And I want you to challenge me if you think that, hey, how come you didn't put that thing in there? So let's go through those things. First thing, right? So let's talk about those challenges. When we started doing some of these things in the early 2000s or even like in the 90s, I don't know if some of you are probably not even born then. So what was happening then was that we had this culture of throw it over the wall. Essentially, we had this people sitting around in like corners trying to do all the kind of like mysterious work. Software developers always write code and then literally throw it over the wall. So what happened? That became a problem because there is always inefficiency when that happens. Why is that? Fairly obvious, right? People who write the code aren't the people who are actually building and testing and doing all the other things. So those people who are building and testing and deploying, and they didn't know enough about the code. So anytime a problem there, they have to actually go back to the developers. So obviously your feedback cycle increased. So what Patrick and Andrew did was provided that legitimacy to the whole idea. Right, so that's when in 2009, they came up with this idea of DevOps. Obviously, that was misconstrued, just like we are talking about. Immediately, people started saying, okay, this term DevOps came. Let's create a bunch of DevOps engineers. And that probably came about. That is not what Patrick intended. So I was talking to Patrick like a few months back at a conference, and we were just talking about this 15 years and all these, the term DevOps and how it came about. He is not unhappy about the fact that it was taken as a team or like as a person or an engineer, because that concept changed a lot of things. So let's look at what happens. So you had the situation of DevOps engineers. I don't know how many of the DevOps engineers look like this, but in my days, they used to look like that. So they used to be sitting in this corner doing all these things, and sometimes you can't even walk into their cubicle because they have like a whole bunch of computers around them, essentially this idea of servers under the closet kind of thing. They used to do all this mysterious things, getting things built and deployed and all that kind of things. So there's a bunch of identity crisis with respect to like, is the DevOps engineer like a software developer, or is that like a build engineer? What do they do really, right? So what really happened was that in 2010, I believe, I think DevOpsDays started in Ghent, if I'm not mistaken. So we came up with this idea of DevOpsDays, right? Which essentially gave a platform for people like us to come together one umbrella, start talking about things in a structured way, which made a whole lot of difference. Together with that, in 2014, we had this, many of you heard of this name, Gene Kim. He is one of the biggest authors and thought leaders within the DevOps space. He started this conference called DevOps Enterprise Summit. Just this year, they have changed the name of that conference to more of an enterprise summit, but this was an amazing conference. This is still an amazing conference. So I've presented there multiple times, phenomenal conference. But if you go to those conferences, what is happening is that for people like us, we really create that identity. We understand where we stand, how that industry is evolving, right? Now, this third challenge, you find that there's so many terms out there. So sometimes it can be extremely confusing, especially new people coming into this. Yesterday, some of us were having this conversation about, a lot of new people are coming into DevOps. But when they come in, it's so difficult because there's so much of terms and so much of terminology there. How do you actually make sense of some of these things? So this is where, at least, there are lots of books that started getting written. I want to call out the 4 books. If you haven't read these books, you should. As a DevOps engineer, make sure that you do read this one. And I will also talk about the 5th book later on. So the first thing is a Phoenix Project. It is actually a story that is, essentially that says that, hey, there is a single point of failure within an organization. You might all, that might resonate with all of you, right? There's this one person who knows everything. And if that person is gone, your organization is completely gone. It's a story about that and how do you actually get out of it. The other one is Accelerate. If you have not read Accelerate, you have to read it. Why is that? Because this was the first time the industry told us that, yes, measuring DevOps and making improvements make a difference to your business as a whole, as opposed to just saying that it's some cool software fad. Third one, DevOps Handbook. This is my favorite book. So it's also written by Gene. The whole idea there is that you take all the story ideas and all those things and make it very practical, usable recipes. And this is an excellent reference book to have when you're really working through some of those things. Fourth one, team topologies. So I think we had multiple references to that yesterday. Even Marco referenced this. The whole idea becoming like you have this DevOps framework and you're using modern ways to improve your software development. What kind of a team structure should you have? How do you actually organize yourself? So it's an excellent book on that one. So if you haven't read those ones, definitely check it out. But this is just a starting point. There are a lot more books. But writing these things down provided that legitimacy more to the whole DevOps movement. Now, next one, emphasizing on the backbone itself, right? So prior to the whole idea of DevOps and all that, the big challenge that you had was that you always had pipelines, but when it comes to deployment time, all kinds of problems. You can never get things deployed, even before the days of continuous deployment, right? Continuous deployment is still more of a pie in the sky for most organizations. You don't need it unless you are an Amazon or somebody like that. You're not going to release like hundreds of thousands of times during the day. So that used to be a huge problem. So how did we solve that? So essentially, again, from ThoughtWorks, we wrote the book on continuous delivery. So if you are using continuous delivery, which I'm assuming that all of you use continuous delivery at some point, that came out of ThoughtWorks. Essentially, a couple of ThoughtWorkers, Dave Farley and Jess Humble, wrote the book on it in 2010. So this actually provided that whole set of constructs that define what's the best way to make sure that your product is continuously delivered and deployed. So now what has happened? So based on that, you can see that things have become a lot more seamless. So you have a way in which you can deliver things. Most organizations do continuous delivery today. Very few organizations still do continuous deployment because they don't need it. But even if you need it, there might be some kind of challenges around compliance and things like that. You need to have somebody look at it, make sure that it is actually ready to go. But it also provided this whole idea of DevSecOps, which we'll get into a little bit later, as well as things like continuous compliance, right? All kinds of security aspects, all kinds of NFRs. Your non-functional requirements could be put into your pipeline so that it becomes easier for you to abstract those things out and make sure that your organizations can actually do the right things. Next one, so the other big problem was that we had a lot of scripting, right? When people started doing DevOps, and it's all about scripting. A lot of us used to write, shell scripts and PowerShell and Bash and Perl and Python and everything, and at the same time, we had all kinds of challenges with respect to repeatability. Your scripts work today in one environment. When you go into the next one, it doesn't work. All kinds of challenges with your drift, right? So how did we solve that? This actually predated, the solutions of these things even predated 2009. As you can see, how many of you use Chef or Puppet? Yeah, there's several of you have done that. So in 2005, Puppet came out, and then I believe it was in 2008, Chef came out. And many of us thought this is the best thing since sliced bread. This is solving all the problems that we are talking about. But then pretty soon things started changing, right? The advent of the cloud and all that became like, yeah, that isn't going to be cutting it. So we started using Terraform in that. So as you can see, some of those automation, those frameworks for putting your infrastructure, defining your infrastructure in a software-defined way, changed the way in which that stability came about. So next trend, let's say we have all these virtualized environments, but what are the problems there, right? Lack of consistency is a huge problem in virtualized environments. Sometimes it's so difficult to create that isolation as a VM if you're dealing with a VM, and then you have to really think about security aspects of it. Then how fast can you bootstrap it? That's again an efficiency issue. The dependency management, we all know that. That became unbelievably conflicting issue that created a lot of challenges there. Portability, huge issue there, as well as how do you actually roll back your environments. So when you had all those things there, came Docker, right? That solved these problems once and for all. So with Docker, what we really started getting is that the software packaging and deployment activities really leading to that microservices architecture. If you're able to package it at that level, then you can really start forgetting about a lot of the other things that we talked in the previous slide. Start thinking about your old concept, which is like, loosely coupled, highly cohesive architectures. So it was so much more easier for us to do it that way. So once the containers came about, we have started getting hundreds of thousands of containers. Orchestrating the containers became a huge problem. So then what happened was that we started creating this multiple containers. We had it, and we had to manage that at scale. We need to have higher availability for that. We need to have all kinds of service discovery around it. We need to find out how do you actually sort of optimize your resources. Then your updates that we talked about, that could be done faster. And then, could we have a software-defined way of doing it, as opposed to just saying that, okay, here is one static way of doing it, and then you have to stick with it. So this is where probably most of us are today. Again, a show of hands, how many of you use Kubernetes? Pretty much everybody, right? So yeah, so this became such a seminal change in the way we started doing any kind of development, right? So the whole idea was that we needed to have a consistent way, highly available way of sort of managing these containers. So that's great. So the next challenge was, you probably see some of these logos, and you might have all kinds of flashback of all the terrible things that happened, right? Remember Equifax? We had this Apache struts, that security vulnerability that created such a huge problem. Similarly, on the Capital One thing, and they are a client of ours right now, but this was, this happened much before that. They had this huge, issue with WAF, right? So they had a security vulnerability there, huge problem. Think of the fact that these things happened quite recently, right? These things happened in like 2017 kind of thing. So even after we started doing lot more secure things, within the containerized environments, within like better orchestrated using Kubernetes and all that. WannaCry, of course, everybody remembers that, Microsoft vulnerabilities. Then, of course, in Europe, we had the GDPR, and then mostly in the US, we had lots of PCI and SOC 2 and all those kinds, lots of compliance things. So you can see the security and compliance activities became to the forefront because of the fact that this is something that people are starting to take advantage of. So which sort of came about, until I did the research, I thought we're all doing DevSecOps for forever. It is not. I think we have started doing a lot more of those things the past 8-9 years kind of thing. So this became a standard way of doing it. DevSecOps is no longer something that is an option. Today you look at it, this is the way anything has to be done. Your security and compliance is not an optional thing, right? So this is sort of built into your pipeline so that it's done consistently and done every time. So so we are doing all of these things, and we are monitoring everything. We are looking at the problems, fixing the problems and all that. But the real question is, like, if your customers are already seeing the problem, is it too late, really? Right? Wouldn't you want to see those problems prior to your customers seeing it? You have your system working, you invested all these things, but if the customers are seeing it, then you've already lost the battle. So that's when the whole idea of observability came about, right? So the way I think of, I'm sure you heard this, right? So your known knowns are things that you know that you can fix. Then you have your known unknowns, which is coming out of your monitoring tools. Then that leads into unknown unknowns, which is what you need to observe. So those of you who are not, I know that some of you actually work on observability here, but those of you who don't do much with observability, the whole idea is it's not same as monitoring, right? It's different. The idea is that you're really looking at what is actually happening, external to a system, and figuring out what is happening internally. That's the whole idea with observability. We'll get a little bit detail into that. So the way I look at observability is that there is at least 8 axes to it. So when we talk about observability, mostly we say, okay, it's an application observability. Yes, application observability is one of it, but that isn't going to solve the problem, because if your infrastructure isn't working well, if your portfolio is not working well, if your actual cloud services are not working well, if your service health isn't working well, if your incidents are increasing and your business outcomes are not there, no good, right? If your application is working great, that's not good enough. So anytime you think about observability, look at it holistically. Look at it across 8 different axes at least. And there are multiple presentations out there, a few conference talks that I have done, as well as other people from ThoughtWorks have done this. We look at this somewhat uniquely in the sense that we look at it more holistically. And this is the only way you're really going to get the benefit of your observability. That's great. So the next challenge was that public clouds, right? Public cloud started coming around in the turn about after early 2010s. So this has started getting really, really popular. We have all kinds of clouds. And which cloud is more popular around here? Do you guys use AWS or Azure or Google Cloud? Can I get a show of hands for AWS? I think it looks like the majority of Azure. Some, okay. And the Google Cloud? I see Azure is lesser than Google Cloud. It's interesting. Okay, so obviously you know that this has created a whole slew of problems, new set of problems. So the way cloud providers started dealing with it is like, yeah, let's have cloud-native DevOps, which again changed the whole landscape with respect to how you start looking at it. And you had this, Google Deployment Manager, you had this, Cloud Formation, or you have your Microsoft ARM templates and things like that. It helps you define your infrastructure better. But at the same time, the more of the advances came out of what you see on the other side. So you have your Terraforms and your Kubernetes, Docker, GitLab, Istio, Argo. I mean, they're all like very cloud-native, cloud-aware kind of technologies that helped you do that. But defining it that way made it a lot more easier for us to start using cloud, because cloud providers didn't have an option, right? They either had to actually find a way to make sure that the existing tools work with their systems, or actually had to come up with something on their own. So even though you have, all these three here, that's the reason I put this on the left side. Terraform is still more popular, or now you should say OpenTofu is more popular. But the fact that cloud providers still provide some of these things is a reason, it's a validation of the fact that cloud providers can't think of things differently. They can't change the direction. They have to go with where the industry is going. Now, the next challenge. If you look at the DevOps lifecycle, which all of you have seen this, the amount of tools is unbelievable, right? And this goes back to that early problem that we were talking about, and we had all these kinds of terminology, and how did we actually solve it kind of thing. Just like that, we had this whole set of tools. The question became like, have all these tools. Every organization you go into has got multiple set of tools for every problem that you're doing. So what's your approach that you should take to make sure that this is at least controlled somewhat? So the solution that people came up with was GitOps. How many of you use GitOps? Or at least you think you use GitOps? Awesome, yeah. So the idea is that, going away from an ecosystem where you have like completely different unrelated tools trying to talk to each other, how do you actually make sure that you create your whole tools ecosystem around one way of doing things? And that consistency is unbelievable, right? I mean, it was primarily started with the Flux and Argo movement, but now if you look at GitHub Actions and GitLab and things like that, just last week I was at a roundtable where GitLab was really asking, like, okay, why is GitLab not as popular as something else, right? I mean, so everybody's now starting to think about, how do I actually help whole GitOps operations get better? To me, this is still, it has already run its course. You probably see less of adoption of GitOps now. I think most people have adopted, who wanted to adopt has adopted it. But this is a phenomenal way of doing things, because GitHub Actions, I love it personally. I mean, I'm sure many of you use that too. But those kinds of systems make it a lot more easier for people to understand and use some of these tools. So we talked about all the tools. Now the question becomes like, what does it all mean? What's the value really? How many of you have read State of DevOps report? At least heard of it? I'm a little bit surprised that you haven't. So let me talk a little bit about it. Again, from ThoughtWorks. So Jess Humble from ThoughtWorks, as well as Nicole Forsgren, as well as a few other folks, started this movement called DevOps report activities. Essentially, DORA stands for DevOps Research and Analysis. What they started doing was they actually started looking at how organizations are using DevOps, essentially from the point of how are they developing stuff, how are they building and deploying and everything, and how is that impacting the business? If you do DevOps well, does it really help your business? Because this is an obvious question to ask, right? Because we are all doing it, because we have vested interest, but even those people who are investing in us, they have an interest in knowing, like, is it really working? So they have been starting this since 2014. They have actually been doing this report called 2014, think so, or maybe a little bit later. This report called DevOps, state of DevOps report, and in there they do a lot of research. So if you haven't read it, I would strongly urge you to go to dora.dev, dora.dev, and download the latest version and take a look at it. But one of the things that came out of this DORA report recently, or like a couple of years back, was like in 50% of the organizations, software developers only spent 30 to 40% of the time doing feature development. Just think about it. 60% of the developers' times are wasted. And these developers are the most valuable resource for every organization. So if we can't improve that, then we have lost the whole battle, right? This is none of these things are worth it. So how do you improve that? So that's where the whole idea of DevX came up. So this is something that is getting a lot of press these days. My team is the one actually doing a lot of DevX research within ThoughtWorks. So essentially, this is based out of developer surveys, right? I mean, so you would think that, that's more. If you talk about surveys, that must be more qualitative and how people feel as opposed to what exactly is happening. No, the research has proved that it is better to look at it from a survey's point of view and then marry that with a more quantitative approach. But developer surveys is extremely important, and so is value stream mapping. Are you familiar with value stream mapping, the concept of value stream mapping? It's fairly simple. You take your overall path to production, right? From the moment you write the code to get it deployed to production. Look at each step in there. See where the friction is, where the most time wasted is happening. So that is your value stream. Then you map it and see how can you actually start improving that. So if you want to improve your SDLC, what you need to first know is where is the problem, right? And by doing the path to production mapping, okay, problem is going to be in step 3 versus step 4. So step 3 problems is bigger because it takes more time to do step 3. So you optimize step 3 and then go to step 4. So that's the whole idea. The other idea that I briefly talked about yesterday in our Ignite talk was this platform value models. So things like when you're building something, some capabilities, is there a way in which you could actually try and measure that, and so that you get more value for what you're building? Then some of you are already using things like Backstage. So the whole idea of if you can actually provide some kind of the internal developer portal, doesn't have to be a Backstage, it can be any of those. If you're providing something like that, is there a way in which you can really make that onboarding process a lot more easier, your developers' experience a lot more easier, right? This also ties into the idea of internal developer platforms, which is not the same at all today. It's completely different things. Portal is essentially what it says. It's a portal into the whole experience. But the platforms are something that we'll talk a little bit later, that includes lots of capabilities in there. So now we talked about all of that. Interestingly, it comes the whole idea of okay, so we build all these tools, we had all these processes, everything is great. Now we have to really look at it from an operational point of view. We did all those things, but we are talking about some examples yesterday, DevOps engineers are supposed to do X, Y, Z, and that is still hasn't gone away. How do you actually address some of those things, right? 5 challenges there if you look at it. So you have significant amount of data for the operations engineers, and we need to have to better identify some of these challenges and then do more root cause analysis. And then automate and optimize. It's a cycle of automating and optimizing, right? So this is where the whole idea of AIOps and certainly AI for DevOps and those kinds, and chat ops and all those things came about. I actually referenced some tools in the industry yesterday, and again, you can go and Google this out. AI ops is something that is still not mature to the level in which I would like it to be. It is being used by a lot of organizations, but the idea is very simple, right? Think about it from the point of view of how do you improve your operational experience? That's all. Make everything based on the measurements, like we talked about earlier, right? So if you're doing it at that level, the idea is that how do you reduce the developer toil? Meaning how do you reduce the amount of repeatable work that can be avoided? That's the whole idea, right? Creating more efficiency. And there are multiple tools coming within this space that is actually changing this. One thing, and again, Patrick Dubois, who's started the DevOps movement, one of his focus areas right now is on prompt engineering. So essentially, the whole idea is that they're asking more about, like, if you're developing prompts better, can that be actually mapped better into activities such as creating better LLMs, and so that you can have a more generative way of sort of solving some of these things? Because predictive AI has always been there, right? Especially within the DevOps SRE space. Predictive AI is a simple concept, so think of it like, so if you are really saying that there is going to be a problem, how can I solve it? Self-healing is a great example of that. But generative AI is essentially going to be taking one more step ahead. And that's where we need to generate those prompts properly and generate the right kind of LLMs. So this is an area where products are coming out right now. You might want to check it out. And this is, I think there's still a lot more room to grow. So today, at best, it is some kind of Slack integration. You can write some prompts saying that I have this problem, solve this problem. That gets translated into some kind of automation that gets implemented. There are tools like that today, and you can easily map those things. So we talked about all of that. And this quote, somebody else also gave this quote yesterday. This is attributed to Peter Drucker, big management guru. Essentially, it says that culture eats strategy for breakfast, right? You can have all the strategy, but if your organization doesn't have the right culture, you're going to fail. So this is where I want to call out that earlier book that I talked about, right? This is that team topologies thing. There are different ways to approach the culture, and the culture is not a simple thing that can be confined to one slide. But one thing you have to think about is that you need to have some kind of a clear organizational structure. Without a clear organizational structure, however good an organization is, you're not really going to see the benefit. You need to have the right kind of boundaries. So you heard that good fences make good neighbors, right? So if you're really having all these kinds of stakeholders within your organization, the best way to get that benefit is to make sure that it's organized well. So you may or may not have seen this, but if you haven't, definitely take a picture of this and read the book by Matthew Skelton and Manuel Pace. Certainly, this is unbelievably good book. One of the best organizational books I've actually read about team topologies. Very simple concept here. So if you look at it, you have this idea of a platform team, which is essentially the team that abstracts out a lot of the common capabilities that then gets used by the rest of your functional teams, the domain teams. And that's what those stream-aligned teams are. So now, with all of those things, coming to the 15th one, we have actually gone through 14 already, right? The 15th one, the idea of platform engineering. So you might still be wondering, this is great, this guy is talking all about platform engineering. I'm still not clear what that is. So let's look at platform engineering from the context of DevOps, DevX, and SRE. So what is DevX? Essentially, the experience for the developers interacting with the tools, technologies, and process through the whole SDLC process. And DevX requires platform engineering. So if you look at DevOps, it's essentially a cultural paradigm, right? It's not a set of people, it's not a job title, but it's a cultural paradigm that improves the collaboration communication between all aspects of SDLC. So platform engineering enables DevOps. So it's not something different, it is essentially something that enables DevOps. Same thing on the SRE. So SRE is essentially applying the software engineering principles to operations. So platform engineering supports SRE. So if you look at it this way, if somebody asks you, somebody tells you that, I don't understand this, use this view. I think that makes it very clear for people that, yeah, DevX requires platform engineering is enabling DevOps, and it supports SRE. So what exactly is platform engineering? Essentially, we have done this again for at least as long as I've been in the industry, I'm sure even hundreds of years, economies of scale, right? If you have 10 people doing the same thing, why don't you actually have one person do that and then repeatedly use it across the board? That's all there is to it. There is no magic here. This is so simple. We have done this multiple times. Just telling somebody that just over the past 2 years, for at least 10 of the Fortune 100 companies, I've implemented this. And since 2014, for 10 years, ThoughtWorks have been doing some kind of platform engineering or not. So this is reality. This is not tomorrow. This is not 10 years from now. This is yesterday and today. So this is happening right now. So what exactly is platform engineering, right? I mean, this would be a good question. So sometimes it's difficult to understand things if you don't scope it well. So And I have this on the ThoughtWorks website too, if you can see my article on that. But essentially, it says like this sort of defines what platform engineering is as scope. So you can see there are 5 key planes in here. The first plane is fairly obvious. It's the developer plane that says, okay, here's the version control, here's the IAC and dev tools and all the kind of things that we deal with. Second plane is your compliance and governance plane. This is where your pipelines and lightweight governance and all those things would come in. Third one is the most important thing when we think about all of these DevOps and platform engineering. That's the thing that comes up. It's your runtime, right? I mean, this is where you talk about your containers, Kubernetes. Even if you look at AWS, I was talking to somebody at AWS at reInvent, and they were saying, yeah, now we have 18 different ways of running your containers, right? So it becomes so complex right now. So you need to have a level of abstraction that simplifies that. The networking and security, fairly obvious, but those has to be part of it. But I don't know if you have noticed already, there are 2 vertical planes there, right? Other than the 5 planes. To me, the single most important thing in platform engineering is what you see on this side, right side. This is the platform product management. The biggest mistake anybody make when they try and build platform engineering or talk about platform engineering is the fact that they think that let's just go build it. Nope, it doesn't work like that. You have to understand why you are building something. It goes back to your question yesterday, right? I mean, so you were asking this yesterday, can we get everybody into a room and just talk about like what exactly is needed? Absolutely. You need to start doing that. If you're doing platform engineering, the first thing to do is to think of it as a product. Get the stakeholders into a room, understand what the stakeholders need. It's never going to happen if you say that you build it and they will come. No, they will never come. So you need to make sure that you build what is right. So that happens with the platform product management. The other side of it is the observability. That spans everything. So remember that 8 axis that we talked about in the observability? Observability spans everything. If you cannot see, if you cannot measure, you're never going to improve anything. So that is the other key plane. So again, think of this like the actual scope of what platform engineering is. There might be situations where some people might be throwing in DevX in here and lots of other terminology and constructs in there. But this sort of captures what typically platform engineering is. And how does this fit in the bigger picture, right? I mean, so you can see that for any engineering organizations to sort of improve, platform engineering is one of the key components. Without that, you cannot actually create that effective engineering. Developer experience measurement and productivity improvements is similar to that. But at the same time, you have your other things like enterprise testing strategy and your domain-driven design and scaling your knowledge. I mean, we talked a lot about that even yesterday. How do you scale the knowledge of an organization? What are the ways to do it? As well as your overall operating model, right? But you can see how important platform engineering in the whole space of trying to improve how an organization works. So the approach to building platforms is, again, we already talked about this, right? Build the right thing. How do you know what the right thing is? By talking to the people who are going to use it. Start there before you actually start building something. Just because something is cool, don't build it. Nobody needs it, right? Just make sure that somebody needs it. Even if it's a little bit less cool, that's okay. Build what people need. Then build it right. And that's where we have all these tools and processes and everything that we talked about. So I want to sort of conclude by talking about a couple of things. So one thing is like, what are the key themes? If you want to have like a takeaway from this, like what are the key themes in the platform space? Number 1, measure your waste and friction. If you can't measure it, you're not really going to improve the right things, right? So you need to measure and improve those ones. Then strengthen the product technical thinking. I mean, so essentially think of this like a product. These are not just some automation you build. If you build that as an automation, never going to have the impact. So make sure that you have that product thinking in there. So if you're ever building a platform team, the first person you need to hire is the technical product manager. If you don't have that person, not going to work. This is not a domain product manager, a technical product manager. Favor buy in a build versus buy world. I mean, this might surprise you, right? So what I'm saying is that, why would you actually go and build something that you can buy? It makes no sense, right? Because there's so much of tools out there. Go buy that, right? I mean, so or look at an OSS version of it. There's no need to actually do something that somebody else has done. Because especially if it's open source, think about the amount of contributions that's having. Yesterday Paul was talking about the open tofu and the kind of the pull requests and all those things coming in there. Why would you ever want to do anything like that other than just go use what's out there? Fourth one, composable, extensible, and replaceable. This is extremely huge, basic tenets of platforms, right? Because you might be actually built, I know, hopefully I'm not giving this away. I know a large financial service organization based out of the US who built their whole ecosystem based on Jenkins. I know there are probably some Jenkins fans in here, but Jenkins has a lot of challenges, right? Compared to some of the modern CI/CD systems. They built all of those things, but they built it in a way that is completely not replaceable. Now they are working with us to trying to re-architect the whole thing. This is something that has been around for about 10 years. Now they have to redo the whole thing. If you don't build things in a composable and replaceable way, you're always going to have the problem. Remember the thing I told earlier? Loose coupling and high cohesion, right? Make sure that your architecture is always like that, whether it is a platform engineering, any kind of software you build. End-to-end lifecycle observability, we already talked about it. You need to have that. Without that, your platforms won't work. Make sure that your teams are autonomous, right? Don't make that you build all these things and say that, oh, you can't do all those things. You have to go talk to my DevOps engineer to do it. You completely lost it, right? You need to make sure that your teams themselves are autonomous. So the journey from having an independent DevOps team to actually having that platform engineering function where teams are self-sufficient is not like an overnight thing, right? So if you as a team decide to have an embedded DevOps engineer day one, that's okay, right? That's a journey where you get there. So the last one, define an articulated value. So we talked about this platform value model, right? Anything that you build, you can actually measure the value. It is not a pie in the sky. It is not something that an abstract concept. We have spreadsheets and models I'm happy to share with you that can literally let you measure how much money you would actually be saving. That's again a conservative way. And if you can't articulate that, then that's probably not what you really want, right? You shouldn't be building it. You might think it's a great thing to build, but if you cannot articulate value, the people who are actually going to pay for that feature are never going to be convinced. So, final slide. You might ask, like, where this is going. Again, this is my opinion on it, right? This is not a fact. Where is all these things going? What's the future of DevOps? What's the future of platform engineering? So I look at it like as 4 different activities. Let's start from the bottom. So one thing that we are seeing a lot today is that internal developer portals, like the Backstages of the world, there's so many different options there. The Port is another option, and a Cortex is another option. There are lots of different tools out there. These things are now converging towards internal developer platforms. Remember the platform, that 5-layer model that we talked about? So think of it like that whole platform model having a portal to get into it. So today, those are completely different activities. Those things are coming together right now. So that's first thing that will happen. The other one is the overall platform convergence. As that ThoughtWorks, I had the, sorry about that. I had the platform engineering part of it, but there's platform engineering, of course, on the engineering platform side of things. But there are business platforms, right? So we talked about platforms in so many different ways, experience and business platforms and all that. So those things will converge. The third one, the embedded DevOps or embedded platform engineering side of things. You are already doing these things today, right? If you are using Kubernetes operators, especially if you are using advanced operator patterns. Anybody using Kubernetes operators? Yeah. So you're already going that route. So the whole idea is that if you are using Kubernetes, that is a great framework ecosystem for implementing DevOps within that. So that's the way it's going to actually evolve. So today it's Kubernetes, the way we orchestrate it. Tomorrow it's something else. But that embedded platform engineering idea is there today. So this is definitely how it's actually going to move forward. The last one, the Gen AI, right? So how would Gen AI help or hurt this process? The way I think about it is that this is really going to enhance the value of what we do. Again, going back to those 5 planes as well as those 2 vertical planes, what if the concepts within that, the ideas that you're implementing within that gets more and more automated, more and more actually done through generative AI? Then the value that you all do becomes higher and higher every day. With that said, I want to conclude. So thank you so much. If you want to connect with me, feel free to do that. You can connect me on the LinkedIn here. And you can check out my website, or just connect me on Twitter or X, or email me if you need it. And the organizers wanted you to actually do and go provide some feedback. So I think we have a few minutes for the questions, if you want to do that.